so please note there's a major change between what we've done and this particular problem that's on the board now. This one has bounds. There are two ways of dealing with bounds on a U sub. Either one is perfectly valid. Kind of depends upon how difficult the substitution of what you're doing is. Okay? But your first thing is you got to pick a U. What should my U be in this particular case? Yeah, the denominator, x squared minus 4. So I let U equal x squared minus 4, and then du equals 2x dx. So that's a fairly straightforward substitution here. I have the integral now of 1 over u du. Here's my dilemma. I can do what we've done. Solve this in terms of u. Put x back in, and then evaluate. Or I can use my u substitution and change my bounds. It's often easier to change my bounds and then just do everything in terms of u. So if I do that, I go back, okay, when x equals 0, what does u equal? Equals -4, right? And when x equals 1, u equals -3. So I change my balance from 0 to 1 to -4 to 3. And then I just do everything in u, and I don't have to worry about going back to x.
Oh, wow.
Yeah. If I change my bounds, I never have to worry about x again. Everything's now in terms of u. Because I changed my function from x to u, I can change my bounds accordingly. And if I solve this, so this is equal to the natural log of the absolute value of u, evaluated from -4 to -3. And this is important that we have the absolute value because it won't work for negative numbers. Okay. And we end up getting the natural log of the absolute value of -3 minus the natural log of the absolute value of -4. And then you can evaluate that on your calculator or not. It is up to you. Okay. If we had not changed our bounds, we could have done it in u, and then when we get to here, we go, oh, if we don't change the bounds, that kind of gets skipped. What you do is you go, okay, well, that's the natural 1 over u du equals the natural log of the absolute value of u, and then I change it back over to the natural log of x squared minus 4 evaluated from 0 to 1. And when I do that, plug in 0 for x and 1 for x, what do I get? I get the exact same thing I just had. So it doesn't matter. It's irrelevant. You'll still get the same answer in the end, whether you change your bounds or don't change your bounds. I am an advocate for changing your bounds. Then you never have to worry about going back again. You don't have to worry about substituting back your x values. Okay? So that's what I prefer, but it doesn't really matter either way. Okay? You'd end up getting the same answer because you plug in 0 and plug in 1, what do you get? You get -3 and -4. Same thing. Questions? Confusion? Consternation? Clear as mud. Your turn. And I don't know why that's not undoing it. Give that one a shot.
Are we still doing?
Pick your U. Okay. So, what am I going to let U be? Yeah. What's inside the parentheses? 2x squared minus 3x plus 5. So U equals 2x squared minus 3x plus 5. Du equals 4x minus 3. Sorry. Yeah, 4x minus 3. Ooh, I screwed that one up, didn't I?
Yeah.
Oh, man. See what I get for trying to do something early in the morning? I did that this morning. I added a few extra problems in there. I wasn't awake. I'd only finished my first cup of coffee, not my second cup.
Should it be minus 6x then?
No, actually, it should have been x squared.
Minus 6.
No, it should have been x squared in the original one, is what my thought was. Just plain old x squared in the first, not 2x squared in the first. That was what my thinking was. So then you would have had to have a pull a 2 out. Does that make sense? So I screwed this one up. This one's my bad. If you picked the right U, you picked that. It didn't work out because of a typo on my part because I only had 1.5 cups of coffee, not 2. Yeah, I was halfway through my second cup and I still wasn't awake yet. This is a long night. What the hell? Okay, so let's do this. Then we can fix the problem. That makes it doable. So, oh, and I forgot something here, didn't I? What did I forget? dx. Thank you very, very much, my dx. So, I have the integral of cosine u du. Makes it nice and straight and easy. So this is the sine of u plus c, which is the sine of 2x squared minus 3x plus 5 plus c. My bad on that one. My bad. You guys, I'm sure we're screwing that one all up. That's it. So questions on this? Other than Mr. Orrs, why'd you screw up? I think I explained everything else. That was a typo on that one. Yeah.
Mr. Orrs, why'd you screw up?
Yeah. Hey, did I turn the sign on? I'm sorry.
Oh, dude, can you turn that on the floor?
Yeah, I can do that. Yeah. Turn it on. Yeah. No. Okay, do this one, and I don't think I screwed this one up. But notice you got bounds on this one. Okay, so the first thing you want to do, pick your U. Choice for U in this one, x squared minus 5x plus 1. And then you get du equals 2x minus 5 dx. Before changing bounds and stuff, make sure this is going to work. I do get the integral of 1 over u du because 2x minus 5 dx, 2x minus 5 dx, that's all there. The u is there. I don't have to worry about anything else. This is a straightforward substitution. Then I have to change my bounds. So when x equals 5, u equals 1. When x equals 7, u equals, what'd you get? 15? 5? 49 minus 35 is 50 minus 35 is 15. Should be 15. Okay, so my new bounds are 1 and 15. So this is the natural log of the absolute value of u from 1 to 15. which is the natural log of 15. And I can drop the absolute value on my evaluation because I know 15 is positive. I'm okay. Minus the natural log of 1. And what is the natural log of 1? 0. So this is the natural log of 15, and that is my exact answer. No, because you're evaluating, so no C on the evaluation.
What?
You only need a C when it's an indefinite integral. When you don't have bounds. When you have bounds, you're evaluating. No, you don't have to worry about that. All right.
I did not know that.
Listen up for this one. Trust me. Okay. You have a couple of homework problems that are just like this. This is perfect for you substitution. I would never expect you to be able to figure out what your U sub would be on your own. I would have a hard time, and I've been doing this problem or something similar to it since I began teaching calculus. So in like 14 years of teaching calculus, I have done this problem or something similar, and if I were to drop in on it and not know what my U sub was, it'd take me a while to remember what I'm supposed to do for it, and I've seen this problem several times. This is not an easy one to choose, but when you see it, you understand why it works. I have my U. Let U equal 3x. Okay, so if U equals 3x, du equals 3 dx. I do not have a 3 dx in here, so that means that 1/3 du equals dx. So I can do most of mine. So what I have now is I now have the integral of 1 over the square root of 3x squared minus 1, sorry, not 3x, of u squared. And the reason I can do this now, and this is a hard one to see, u squared minus 1 du, is because what is 9x squared? But that's 3x quantity squared, right? That's why I let u be 3x, is to do that. But I've got a problem here. My problem is I still have an x in the original problem. I still have this here that is unaccounted for in my substitution. I have not technically replaced that with anything, have I? Technically, my x is still here, but I can't have that. I can do a substitution, though. If u is equal to 3x, 1/3 u is equal to x. So I take this x here, replace it with 1/3 u. To make my life simpler, too late. Take that 1 over 1/3. Well, what is 1 over 1/3? 3. Pull it out front. So I get 3 times the integral of 1 over u square root of u squared minus 1 du, and the antiderivative of that, yes, yeah. You're right. So I replaced the dx with 1/3 du. So I have another 1/3 already, right? So I already had the 1/3 out here. So this should actually be a 1. Thank you for pointing that out. Does that make sense? Do you see that? Because I have the 1/3 du to replace the dx, and then the 1/3 times 1 over 1/3 gives me 1. So this gives me the secant inverse of u plus c, because the derivative of the inverse secant is 1 over u times the square root of u squared minus 1. And this is where if you know your derivatives, your antiderivatives work well. Equals the secant inverse of 3x plus c. Oh, thank you, thank you, thank you, thank you, thank you. Oh, I gotta tell my wife I used to that thing all the time. I do. I need a remote and I need to mount it up there. That's what I need to do. I gotta figure that out. Okay, I do have one other thing for you though. One more problem to do.
The cabin?
Yeah, the integral of 1 over cap and p cabin.
What's cabin?
It's a house boat. The antiderivative of 1 over something is?
Oh, plus C.
Natural log cabin plus c.
So funny. So funny.